Hello everyone, this is Shankar and welcome to another video. In this video I'm going to talk about functional interfaces, and I'm going to talk about some of the important functional interfaces that have been provided in Java 8, and we're going to try to understand what functional interfaces are in the first place. So let's go ahead and create a new project. So I'm going to say Java project. I'm going to create a Java project, and let's name it Java 8. And click on finish. So we should make sure that the Java version that we're using is Java 8, right? And I'm just going to click on finish. So we have this project here, and inside the src folder, we're going to create a new class. I'm going to call this demo, and let's have the main method for this class. Okay, so now we have our class and everything set up. So now let's try to understand what functional interface is. So basically a functional interface is an interface that exhibits a certain functionality, or that represents a certain functionality, or that helps us achieve a certain functionality. And in other terms, a functional interface is basically an interface that has one abstract method. So in Java 8 we have this package called java.util.function, and it contains some of the very important functional interfaces, right? So let's take a look at the first functional interface that we have inside our java.util.function package. So we have this functional interface called Predicate. So let's take a look at how it works. So I'm going to say Predicate, and I'm going to import this. So if you can see, this is inside java.util.function package, right? And let's take a look at the source code for Predicate. So this is a functional interface, and it is annotated as a functional interface. And when we are annotating, when we annotate an interface as a functional interface, it expects to have one and only one abstract method inside it. So we have this abstract method called test inside Predicate, and Predicate takes in a type parameter, and this type parameter is used as the input parameter for the test method, and the test method returns a boolean value, right? And this is since 1.8, right? So let's try to implement this, and let's see how this works. So I'm going to say string. So this is going to be the type parameter for this interface, and the test method is going to accept a type, or going to accept an input parameter of the same type as we pass in here, right? So we are passing in string as the type parameter for Predicate, and this test method should accept a type which is of string, right? So let's go ahead and name this. I'm going to call this Predicate, and I'm going to use a Lambda function to implement this abstract method. So what I'm going to do is I'm going to name the variable as, so this expects a string input, right? This expects a string input parameter. So I'm going to call this name, and this should return a true or a false. This should return a boolean value, and I'm going to say name dot starts with capital A. So if this if the name starts with A, we'll be returning a true, and if it doesn't start with A, we'll be returning a false, right? Now let's try to print this, or let's try to test how this works. I'm going to say Predicate dot test. So that's the method that we're trying to call, that's the method that we're trying to invoke, and I'm going to pass in a string, let's say ABC, and let's try to run this as a Java application. So we get a true because this starts with A, right? Now let's change this to def, and let's run this again. So we get a false this time, right? So that is how predicate works. And let's take a look at the next functional interface. So we have a functional interface called function, and it takes in two type parameters. So let's first take a look at the source code for this. So this is a functional interface which is available since Java 1.8, and it takes in two type parameters, right? So the first type parameter is for the input, and let's first take a look at the abstract method for this functional interface. So we have an abstract method called apply for this functional interface called function, and it returns a type which is R, and it takes in a type parameter, or it takes in a parameter which is of type T. So we need to pass two type parameters for this functional interface, and the first type is of the input that we need to pass into this abstract method, and the second type parameter is a return type for this abstract method, right? So let's say we want string as the input type parameter, and let's say we want integer as the output type parameter, and I'm going to call this function equals. So to apply the lambda function, we need to have this variable passed into the apply method, right? So I'm going to say, and that's going to be of type string, right? So the first type parameter indicates the type of input that this method is going to take in, and that is of type string. So I'm going to say name, and this should return. So I'm going to say name dot length. This is going to return an integer, right? Rather, this is going to return the length of the string that is passed into the apply method, right? So let's try to test this. I'll just comment this out, and let's say function dot apply. So that is the method that we are trying to call, that we are trying to to implement on this string. So I'm going to say computer, right? And I'm going to print this and run this. So we have 8 because the word computer has 8 characters or 8 letters in it. So that is why this returns 8, right? So this function functional interface takes in a certain type, and it can return another type of output, right? So we specify what the type of input should be, what the type of output should be, and accordingly it gives us the result, right? So that's about functional interface. And we have next up we have unary operator. So I'm going to say unary operator, and let's first take a look at the source code for this. So this is again a functional interface, and this takes in a type parameter as well, right? And this extends function, right? So this function, again, we have taken a look at this function functional interface in our previous demo, this one, right? And this accepts a type, an input, a type of input, a type of output, and here we can see the type of input and output are same, and this is extended by the unary operator, right? And the unary operator inherits this method apply from function, right? So it takes in a type parameter, and it returns the same type of output from this method called apply, right? So let's take a look at how this works. So I'm going to say this is a string, right? And I'm going to call this UNOP equals, so this should take in a string. So this is basically the apply method that we are trying to implement here using the Lambda function. And this should take in a type, this should take in an input, and the input is of type string. So I would say this, I would call this, name this variable as name, and what we are, so this should return the same type, unary operator. So unary operator basically takes in a certain type of input, and it returns the same type of out. It gives the same type of output, right? The output from the apply method is of the same type as of the input, right? So what we are going to do is we're going to say name plus let's say 1, right? And I'm going to comment this out, and let's print something. So I'm going to say UNOP dot apply. So this apply method is inherited from the functional interface, because this extends the functional interface. And we're going to say, let's say computer, right? And let's try to print this. Go ahead and run this. So we get computer 1. So it takes in a type of input, and it returns the same type of output, right? So we passed in string, and the output type is also string for this, and it gives us the output, right? So similar to unary operator, we have binary operator, right? And let's take a look at the source code for this. So this is again a functional interface, and it is available since Java 1.8, and this extends by function, right? So we're going to take a look at we're going to understand how binary operator works. So let's get inside the by function interface. So this takes in 3 type parameters, T, U, and R, right? And this again has the same this again has the same named abstract method called apply, and it takes in 2 types of parameters, T and U, and it returns now a 3rd type of parameter, R, right? So that's about by function. Now inside the binary operator, the by function parameters are same. So this would take in T, and this would also have T as the type parameters for by function, and this is extended by binary operator. So in simple terms, what binary operator does is it works similar to unary operator. It takes in 2 inputs which are of the same type, and it returns an output which is similar or which is same as the type of the input, right? So let's have integer, right? And I'm going to call this bin op equals, so we're going to pass in 2 integers, and I'm going to name them A and B, and just going to produce the sum of this. So this would return the sum of A and B, right? So what we are doing here is we are taking into 2 variables which are of type integer that we have defined here, and this returns an integer as well, right? So the return type and the type of the input parameters are same, right? Now let's try to print this. Let's try to test this and see how it works. So I'm going to say bin op dot apply, and let's pass in 3, 4, and let's see how this works. run this. So we have the sum of 3 and 4, and we have 7 here, right? So that is how a binary operator works. Now let's take next up. Let's take a look at consumer, right? And let's take a look at the source code for this. So again, this is a functional interface, and this is available since Java 1.8, and all these are inside the java.util.function package, right? So we have these inside the java.util.function package, unary operator and binary operator. Everything is inside java.util.function package. So that is something we need to remember, that these functional interfaces are inside the java.util.function package, right? So let's take a look at consumer. So this is again a functional interface, and it has an abstract method called accept, right? And this doesn't return anything. This is a void, and it just this again takes in a type parameter, and the input type for the input parameter is of the same type that we are passing in here. And this accept method just does some processing to the input, and it doesn't return anything, so it's just void, right? So let's say input is of, so let's keep the type parameter as string, and I'm gonna call this consumer equals. So what I'm gonna do is system.out, and I'm gonna say just print. So this is again a method reference that I've used. So what this is going to do is it's going to basically print the string that we pass in. So if you take a look at consumer, it has one abstract method called accept, and this takes in a parameter which is of type string, because we have mentioned the type as string here, right? And what it basically does is it prints that string. So this is a method reference, and we'll talk about method references in some other video, and this video is not about method references, and I'm not going to go into the details of method references, and this is just method reference that I've used here, and we're just printing the string that we are passing into the accept method of the consumer functional interface, right? Now let's try to test this. I'm going to comment this out, and I'm going to say system.out, and let's say, all right, we don't even need the system.out, so I'm going to say consumer dot accept, and I'm going to say computer and let's try to run this. So we have computer printed. So what this is doing is this is basically taking in a string and it's just printing it out. So even if we don't give it inside a system.out.println, it is still printing it, because this accept method is just taking in a type, or taking in an input parameter which is of type string, and it is just printing it out, right? Consumer. And we also have supplier. So again, let's take a look at the source code for supplier. So this is again a functional interface, and it is available since Java 1.8. It takes in a type parameter of type T, right? And it has a get. It has an abstract method called get, right? And it doesn't accept, or it doesn't take in any input parameter, and it just returns. It just returns a type which is of T that we have passed in here, right? Now let's try to see how this works, and we're gonna say integer, right? And we're gonna say supplier equals. So this doesn't take in any parameter, and we're gonna just give the empty braces, and we're gonna say return, say 50. We're just returning 50, right? Or yeah, just let's return 50. And so basically what we are doing here is we are trying to implement this get method that we have, abstract method that we have. So this doesn't take in any parameter, so we have just kept these parentheses empty, or these brackets empty, and we don't have any variable that is being pushed in. And this returns a type which is integer type, because we have mentioned integer here. T, the T that we have here is a type of parameter that is returned from this method. So we are saying that this should be integer, and we're just returning an integer which is 50, right? Now let's try to print this. So I'm gonna say supplier dot get, and this should not be taking in any parameter, because this abstract method doesn't accept any parameter, and they should return us 50, and they should print 50 on the console, right? So we have 50 printed on the console. So these are some of the important functional interfaces that has been provided since that are available since Java 8, and there are various functions, or there are various methods that take in types which are functional interfaces, and it is very important. It is really important while dealing with Lambda functions and other stuff that we have with Java 8. So that is all about functional interfaces, and that is all about this video, and I hope you guys enjoyed this video, and if you did enjoy, please give it a thumbs up, and thanks for watching.